practice problem 2. Let's factor the 4 into 2 times 2. Now, the x to the 5th, we have an x to the 4th here, x to the 3rd, and we have an x. So what we technically can do is we can take the smallest exponent of x, which happens to be 1, and we can break down the others so that it has one of the smallest exponents of x. What I mean by that is I can now say I want that x to the 1st, but because this is a 5, I'm going to need 4 more. Okay, I'm going to do the breakdown to 24. We kind of did that before. That was 2 times 12. So 12 can be 3 times 4, and 4 can be broken down to 2 times 2. But now I'm going to be very clever with the x. I'm going to have my x to the 1st, but I need 2 more because I have an x to the 3rd. Plus my 8, which is 2 times 2 times 2, and x to the 1st. So this is one way of doing it without having to write out the x's too many times. And now we can box in what's in common. So we have a 2 that's in common, 2, 2. We also have another 2 that's in common. And we certainly have an x to the 1st that's in common. When we group these together, we get our 4x to the 1st. And then what's left over is just the x to the 4th. Minus 4x to the 1st. And what's left over is that 3, 2, and x squared. So that's 3 times 2 is 6. So that's 6x squared. Again, we get the 4x here. And the only thing that's left over is that 2. So GCF is equal to 4x. And our final answer is going to contain the GCF. And we're going to do the distributive property backwards. We're now going to write out whatever's left in one set of parentheses. And this is our final answer.